You know that dream we've all been sold on? The sci-fi promise of these amazing AI agents, these flawless assistants that are going to automate our entire lives. But then you try them, and the reality is, well, often pretty frustrating. There is this massive gap between the hype and how they actually perform. So what is really going on? Why are these incredibly powerful tools so fragile?
And hey, don't just take my word for it. Sayash Kapoor from AI Snake Oil puts it pretty bluntly. Agents don't work very well today. And notice what he points to next: AI engineering. This isn't just about what an AI can do in a slick demo. This is about how we can make these tools actually work, consistently, in the real world.
So this whole situation creates what we can call the agent paradox. On one hand, you got this incredible ambition, this massive hype. And on the other, you've got a reality that's just full of failures that leave most of us disappointed.
And when you put them side by side, the contrast is, well, it's pretty stark. The vision is this perfect assistant, right? But the reality is often just failure. I mean, look at Do Not Pay, a startup that claimed it could automate a lawyer's work. They ended up getting fined by the FTC for making false claims. Or even the really high-profile stuff like the Devon coding agent. A recent analysis found it only succeeded in 3 out of 20 real-world tasks. That's a success rate of less than 20%.
So this is the big question, right? We have these unbelievably powerful language models that are the brains of these agents. So why on earth are they so fragile when you actually try to put them to work?
Well, to answer that, we've got to pop the hood and take a look at how these models are born. It really all boils down to this fundamental 2-stage recipe.
The whole process breaks down into 2 key stages. First up, there's pre-training, and second, there's fine-tuning. And trust me, understanding the difference between these two is the absolute key to seeing why reliability is such a massive challenge.
So let's start with pre-training. Think of this as the AI's version of a general education. Andrej Karpathy had this famous line where he called it a lossy compression of the internet. Basically, the model just reads a huge amount of text, and its only job is to learn how to predict the next word. And by doing that over and over, it builds this vast general knowledge base about language, logic, and pretty much the world.
Okay, so after pre-training, after the model has its massive internet brain, that's when fine-tuning comes in. This is where the model learns to actually be a helpful assistant. We take that super knowledgeable model and we train it on a much smaller, really high-quality data set of perfect conversations. This is what teaches it the specific style and behavior of a helpful chatbot like ChatGPT. So here's the core difference in a nutshell. Pre-training is all about getting knowledge, just understanding the world. Fine-tuning is all about alignment, shaping all that knowledge into something that acts like a helpful conversational assistant. To put it really simply, one builds the brain, the other teaches it manners. Okay, so now that we know how they're built, we can finally get to the heart of the problem. This is the real engineering challenge we're talking about, the gap between capability and reliability. And this really brings us to this central hurdle in AI today. It's not about making a model that can do something amazing one time. It's all about building a model that does it reliably, every single time, without fail.
Sayash Kapoor defines this perfectly. Capability means what a model could do. Reliability means consistently getting the answer right. Think about it for a second. An AI that can book a flight is a cool demo. But an AI that books the wrong flight even 1 out of 10 times? That's a totally useless product. That is the difference.
Now, when a machine learning engineer is building a model, they might hit, say, 90% accuracy on a task. And, that sounds pretty good, right? For a lot of academic papers, that's a huge success. But for a real-world product, something that people actually depend on, 90% is nowhere near good enough. What an AI engineer is really chasing is what's known in the industry as 5 nines of reliability, 99.999%. That's the standard for systems you can actually trust. It's the difference between a cool demo and a tool that actually works.
And this is the job. The real, the difficult, and the often totally unseen work of an AI engineer today is closing that enormous gap between a model that's 90% capable and one that is 99.999% reliable.
So how do we even begin to close a gap that big? Well, it requires a fundamental shift in mindset. We have to move away from just discovering a new cool algorithm and start embracing the hard discipline of engineering. And this brings us to what I think is the most crucial takeaway of all. The future of AI progress isn't just about building bigger and smarter models. No.
It's about applying good, old-fashioned, rigorous reliability engineering.
And to really get this shift, let's take a quick trip back in time. Sayash Kapoor draws this powerful analogy to the 1946 ENIAC computer. It had over 17,000 vacuum tubes, and they used to fail so often that the computer was literally down half the time.
Just think about what that meant. The main job for those first computer engineers wasn't about inventing new theories of computation. It was the grueling, thankless work of making the invention actually work. They had to swap out tubes, redesign circuits, and build systems just to make it reliable enough to be usable. And that is exactly where AI engineering is today. We have the amazing invention. Now we have to do the hard work of making it work, every single time.
And so that leaves us with this one critical question. We know these models are going to get more and more capable. The scaling laws pretty much guarantee it. But capability on its own is not enough. The real question is, will we, as the builders of this technology, develop the engineering discipline required to make these powerful tools truly reliable? Because that is the only way we will ever close the gap between that science fiction promise and our everyday reality. That's the challenge that's going to define the next decade of AI.